Alright, so my name is Brian, and today I'll be going over the 2020 USACO December contest problem number 2, rectangular pasture. Now, when this problem came out during the contest during December, I think many students were quite surprised that regarding the difficulty of this questions, as this is easily the most difficult question out of the 3 questions this December, and also one of the most difficult questions, if not the most difficult one in recent years. But today I'll be walking through not just how we can solve this problem, the general solving approach, but also the approach that'll help us be able to pass all of the 20 test cases. So let's begin. Now, let me read the problem first, and then we'll do a deep dive into the solutions that are wrong, solutions that will pass you a certain number of test cases, as well as a correct test case that, as you can see here, that can pass all 20 test cases. So let's read the problem. Farmer John's largest pasture can be regarded as a 2D grid of square cells. Picture a huge chessboard. Currently, there are N cows occupying some of these cells. N is between 1 to 2,500. Farmer John wants to build a fence that will enclose a rectangular region of cells. The rectangle must be oriented so its sides are parallel with the X and Y axis, and it could be as small as a single cell. Please help him count the number of distinct subsets of cows that he can enclose in such a region. Note that the empty cell should be counted as one of these. Okay, so basically what this question is talking about is, let me use the drawing board to demonstrate this. Okay, so imagine that you have a square cell, right? So you have something like this, kind of similar to a chessboard. Okay, and it must be oriented, so the rectangle must be oriented so its sides are parallel with the x-axis. So Farmer John wants to build fences in this, in this, think of it as a large 2D grid of square cells, or a chessboard. Now, inside of these chessboards are going to be cows. So as you can see, please help him count the number of distinct subsets of cows that he can enclose in such a region. So note that the empty set should be counted as one of these. Now let's look at the input to think about this question. So the first line contains a single integer, and each of the next n lines is repetition, contain 2 space separated integers indicating the x, y coordinates of the cow cell. All x coordinates are distinct from each other, and all y coordinates are distinct from each other. All x and y values lie in the range 0 to 10 to the 9. So let's copy this input here. So essentially, for the first line, it's going to tell us the number of cows, and then for each of the next lines, it's going to be telling us the location of each of the cows. So the x location, think of the first part is the x location, and the second part is the y location. So in this case, there's a total of 4 cells, right? And then let me label the graph. Looks like we need one more row above. Okay. All right. Okay. So in this case, cow 1 is at 0, 2, cow 2 is at 1, 0, cow 3 is at 2, 3, cow 4 is at 3, 5. Okay, so those are our 4 cows. Now, the question that this problem is asking is, what's the maximum number of fences that can enclose? So how many fences can you have enclosing unique cows, a unique set of cows? And this can be 1 cow, 2 cows, 3 cows, so on and so forth. So if we're just looking at this question, then we know that we could have one cell enclosing just this cow, one cell enclosing just this cow, one cell enclosing just this cow, and one cell enclosing just this cow. So we have 4 cells. And then they're also telling us to include one that doesn't enclose any cows, so that would be like an empty cell. So that would be another option, and that would be 5. And then another option would be we create a fence that encloses these 2 cows, right? That's another option. So, and then a fence that encloses these 2, that's another option. A fence that encloses these 2, another option. You get the point. So another option that includes these 2 cows, that's another one. And those are all the 2 subsets. Did I miss any? So 1, 2, 3, 4. I think that's it. And then there's also fences that can include 3 cows. So for example, like this one here. This is one that can include 3 cells. So that's another fence. And then we could also create a fence that includes these 3 cows. So that's one more fence, right? And then how many do we have? So we have 4, 5, 6, 7, 8, 9, 10, 11. And then let's see. And then so we counted these 3, and then there's also one that can include these 3. So that's 12. And then the last one is we have a fence that can include all of these cells, right? So as you can see, these add up to equal 13, which is our answer, which is the number of distinct cells that you can have. Now let's look at what they want us to output. So what they want us to output is obviously the number of distinct fence options, but the way that they analyze this is they did 2 to the 4th, so 2 to the 4th, which essentially is some permutation. I won't explain. That essentially gives you all the possibility to enclose 1 cow at a time, 1 cow in one fence, 2 cows in one fence, 3 cows in one fence, 4, so on and so forth. So it's 2 to the n, where n is the number of cows, a number of subsets total. But let's look at, they said Farmer John can create a fence enclosing only cows 1, 2, and 4. So let's say that this is cow 1, this is cow 2, this is cow 3, this is cow 4, and it said cannot create a fence enclosing only 1, 2, and 4. So think about a fence that encloses 1, 2, and 4. It's this fence, right? That's the same fence that encloses 1, 2, 3, and 4. So basically what they're saying is if you want to create a cell that includes 1, 2, and 4, you have to also include 3, because as mentioned in the problem, this cell has to be, or this fence has to be parallel. Its 2 sides has to be parallel to 4 sides has to be parallel to the y and x axis. So we have to have a cell like this. And another possibility that's not valid is just having a cell including 2 and 4, right? That's this cell. So this cell has to include 3. That's why 2, 3, 4 is a possible it's a valid possibility, but 2, 4, just 2 and 4 is not a valid possibility. And 1 to 4, that's, this. Also, you have to include 3. So that's why if you subtract the total number of all possibilities, whether it's valid or invalid, with the invalid possibilities, that'll give you the number of valid possibilities. So basically what they're doing is they're doing subtraction. But the problem with this approach is that, as you can see, n can be as large as 2,500. And if you do, for this case, n is 4, so 2 to the 4, very easy. That's pretty doable. But what what happens if you do 2 to the 2,500? That'll be an incredibly large number, so large that if you try to plug in that number in your calculator, that won't give you a that'll tell you yeah, actually let me try to show you the exact words. So that'll say overflow error, right? Because the number is way too large for even a calculator to handle. So that's why it's not really possible for us to just find all the possibilities and then try to eliminate the invalid ones. So how about we just try to find all the valid possibilities? Okay, so then you may say, let me go back so you can see this board more clearly. Okay, so what if you said, let's just count all the valid possibilities. Let's say we count all the ones, all the fences that can only include one cell. So that would be a fence that only includes this cell, this cell, this cell, and this cell. So that's 4 total possibilities. And then you say, okay, let's find the cells that can include, let me change my color so you can see more clearly. So let's say we want to find the cells that include 2 cells. Sorry, the number of fences that can include 2 distinct cows. So this is a valid possibility. And then, so you just go like this one, compare with this, and then compare with this. So that's another possibility. That's 2 possibilities. And then you connect with these, and you see this is 3, so it doesn't count. Now, starting from this one, this is another possibility. So 3 possibility. 2 from, let me label these again. So from this cow to this cow, it's not possible because you also have to go through the 3rd cow. So that's only 3 possibility, and then the 4th one is between these 2, so that would be another add 4, right? So, and then you might think, okay, and then I just find one that includes 3 and then 4 and so on and so forth, right? So the problem with this approach is if you have a number that's as large as n, every time you have to go through so many cells in order to calculate that, and then you have to do the same thing n number of times. That would be way too large. It might be able to pass the first. I actually tried this approach on the contest, and it was able to pass the first 3 test cases, which is already pretty good. But then 3 out of 20 is pretty bad because it's like a n to the 4th or n to the 5th or even n to the 6th algorithm. So then you might think, okay, so if that approach doesn't work, then maybe the best thing we can do is just try to find the number of paths just by looking between 2 cows, and that would be the right answer. So let me repeat what I said. Essentially what you're trying to do is look at every pair of 2 cows and try to find the number of possibilities that you can fence, or the number of possibilities that you can create a fence that includes those 2 cows. For example, if you want to fence cows 1 and 2, right? There's only one possibility that you can fence them. That's just 1 and 2. If you want to fence 1 and 3, that's only one Well, if you want to fence 1 and 3, that would then be 2 possibilities, because you can fence 1 and 3 only, or you can fence 1, 2, and 3. So that would be giving you 2 valid possibilities. Now, if you want to fence 1 and 4, that would be 2 possibilities as well. As you can see, you can fence 1, 3, and 4. And you can fence 1, 2, 3, and 4. You cannot, however, fence only 1 and 4, because any fence that includes 1 and 4 also must include 3. So that will make our algorithm much faster. So essentially what we're doing is just trying to find, for this case, connection between node 1 and node 2, node 1 and node 3, node 1 and node 4, 2 and 3, 2 and 4, 3 and 4. So all we need to do is look at how many ways can we create a fence around 1 and 2? How many ways can we create a fence around 1 and 3? How many ways can we create a fence from between 1 and 4? So on and so forth, right? Okay, so knowing that is a big improvement from our previous algorithm, which is trying all possible sets of whether it's 1, 2, 3, 4, or n minus 1 or n number of cows. Here we're just looking between a pair of 2 cows. But another problem arises, which is that how do we know the number of sets or the number of ways we can fence 2 cows? Well, let me give you an example. Let's say we want to fence 1 and 4. How many ways does it give us, right? This is a fence. So let me just tell you the algorithm for this, and then you'll probably understand it intuitively. So you want to find the number of cows between these two x values that are above them in y value, and we want to find the number of cows that are below these two that are within these two that are below them in x value. So we can see 4 is the highest, so there's nothing above it, and then 2 is the lowest. And then we want to so let's say we have a variable called low. This low would be 0, or low would be 1, and then high would be 0, right? The reason why high sorry, I take that back. So low is 2 and high is 1. So including this fourth node, there's only one node at the same height and above it within this boundary 1 and 4. And then below 1 and 4, but also within its x boundary, we have 2, and also y is, we also want to look at the same the node on the same level, so that will give us 2, right? So that's how we define low and high. So once we know low and high, then essentially what the number of cows, the number of fences we can create is just low times high. Low times high, right? All we need to do is just find low times high. So low times high is 2 in this case, so there's 2 ways we can go from 1 to 4. In other words, there's 2 ways we can create a box, create a fence around 1 and 4. One is 1, 3, and 4. The other one is 1, 2, 3, and 4, right? Okay, so this is a pretty simple example, and I guess you can do some more complicated examples, but due to time, I won't be going over those. But I'll give you an example here that's relatively more complicated. So just for your understanding. So let me say now instead of n being 4, let's say n is 6. Okay, 1, 2, 3, 4, 5. So now n is 6. Okay. Alright, so for this example, we're going to have something like this. Okay, 1, 2, 3, 4, 5, 6. Okay, so 6 cows. First cow location is 0, 1. Okay, and then the second cow's location is 1, 2. The third cow is 2, 6. The fourth cow's location is 3, 4. 4, 0. 4, 0. And then the fifth cow is 5, 3. 5, 3. And then the sixth cow is gonna be 7, 5. 7, 5. So that's another example you can look at. Once again, I'll just talk about, for example, if you want to find the number of ways you can create a fence enclosing these two cows, cow 4 and cow 2, then all you have to do is you look at, so you establish the right boundary and then the left boundary. So right boundary is cow 4, right boundary is cow 2. That'll define the x values, or the x boundaries. And then you try to find the number of cows that are at the same, that are within this x boundary, that are either above the higher cow or on the same level. So that's this cow, which is on the same level, and then this cow, right? The reason why this doesn't count is because it's not within the x boundary. So that's 2. That'll give you the what we call high in this case. So let me actually write this. So high is equal to 2. And then low, what low would give you is, it will give you, so this is 1 and then this is the other. So the number of possibilities is 2 times 2, which is 4, right? And if you think about it, 4 is the answer, because you can go from this to this directly, this to this to this, which is a cell enclosing these 3 cows, and then this to this to this. This is another option, and then including all 4 of these, so that would be another option, right? So that's 4 options. So that's our solving approach for this problem. And now you may be wondering, okay, so will this still satisfy our time constraint? And the answer is no. So that's why we need to compress this, right? Because as you can see here, any algorithm that's more than 10 to the, that's more than n to the, O of dimension, which is the xy value, the maximum xy value, which is 10 to the 9. 10 to the 9, if we're dealing with 10 to the 9, we can only do a linear algorithm, which pretty much never works because we're dealing with a 2D grid. So it has to be at least this, I guess, x and y value squared. So what we want to do is compress or translate that into O of n squared. And O of n squared, which is 2,500 squared, will be able to pass us all the test cases. So how will we do that? Now, if you realize in the question it said that all the x and y values are distinct from each other. So that means, what that means is that we can be able to create a rank order of the x and y values instead of looking at them based on their coordinates, because there could be very large gaps between the coordinates, and that would take us a very large amount of time to actually go through them. So for instance, if we have like a number, the first x coordinate is at like 1, and then the second one is like 957, for example, we have to go through every single one of them, and that'll take way too much time. So what we're going to do in this case is create a what we call a prefix sum. So that's why we have to use prefix sum in this case, because we want to translate x and y values into O of n squared, into n. So, and that wouldn't be too hard to do, right? So if we have these points, all we have to do is rank them based on their order. So we have 0, 1, let's see, 0, 1, 2, 4, 5, 7, right? We can just rank them. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5. This is what we're going to have after we rank them. And then we also rank the y order based on the same principles. So as we can see, this y is associated with the 0th, which is the smallest y, is associated with the 4th element. So that would be 3, 0. And then this is 1, the second largest, third largest. This is the 4th largest. This is the 5th largest. And this is the 6th largest. So now, instead of looking at the actual coordinates, we reduce this down to n times n, which is the ranking of these coordinates. So if we were to produce a graph again, that would look something like this. Okay, so that would look like 0, 1, 1, 2, 2, 5, 3, 0, 4, 3, 5, 4. And then using this, we'll be able to find the number of cows below and above 2 cows, and then we'll be able to find the subsets. So once we know this, it's still not enough. We still need to create a prefix sum, which essentially aids us in our calculation when we're trying to find the number of ways we can include 2 cows. So what this prefix sum list is going to do is it's going to give us the number of cows that goes from the point 0, 0 to the point ij. And ij is where I is between 0 and n, and j is between 0 and n. So all values between 0 and n. So this is pretty easy to construct. So let's say if we have a list like this one, but I'll just let's see what I can do. So let me change a color. So for here, all we want to do is just find the number of cows from 0, 0 to that point. So from 0, 0 to 0, 0, there's no cows, so 0. And then from here, there's no cow, here there's no cow, and then here there's 1 cow, so we're going to put 1. And then once again, here there's 1 more cow. Sorry, they're including this cow, there's still only 1 cow, so there's 1. Right? If you draw a rectangle like this, then that would be only 1 cow. So 1, 1, and then I think you get the point. Here you have 1, and then 1. So here, if you're looking at this, it's just like a rectangle that includes these 4 points, these 4 grids. So 1, and then here you have 2 because you're drawing a rectangle like this, and then you're including both of these. So let me quickly finish off the rest of the prefix sum. Okay, so that's pretty much our prefix sum list. And what this will give us is, let's say we're looking at this grid. What this grid gives us is the number of cows that we can include if we were to create a fence like this. Right? So this would include 6 cows. And how about this value? It's just this fence will be able to include 3 cows. Alright, so now that we created the prefix sum, how are we going to use this? Well, in order to find the number of cows between, let's say, these 2 points, right, what we need to do is we need to find the number of cows within its x and y bounds, within its lower x and maximum x bounds, so within these 2 bounds. We want to find what's above it, which is greater than or equal to its height, and what's below it, which is this part. So to find this, pretty much what you're looking at is the value from here. You're looking at how many cows are here and how many cows are here, how many cows are here, and how many cows are here. And that's pretty easy to do once you have the prefix sum, right? So all you have to do is find this area, and then that'll give you the number of cows from 0, 0 to this point. And then in order to find what's over here, you have to subtract this bottom part. So that'll be the value here, and then you have to add back, let's see, so you have to find the value of this and then subtract from this, subtract this, and then add, one second. So, oh, okay. So if you're only trying to find what's above, then it's going to be this part. So that would be the whole thing, subtract from the bottom part, but also there's this part that you have to subtract. But you can only go from 0, 0 to here, so you also have to subtract this part. And then since you subtracted this part twice, then you have to add back this part. So that'll give you the area of this part, right? And then for the bottom part, it's going to be easier, which is you're going to find the number of cows, or as I like to say, the area, which is not really right, but you can think of it as an area, because this number here will give you the number of cows from 0, 0 to here, which is 2 in this case, right? 2. Okay, so find this, and then all you have to do is subtract it from this part, and this works, right? And this will give you the number of cows below it. And then to find the number of cows above and equal to and below and equal to, basically all you need to do is find those two values, plus them by 1, right? And then multiply them. That'll give you the number of ways you can fence these two cows, right? And this works for pretty much all cases. All right, so hope you understood the algorithm, how it works, and then next we're going to move on to the actual implementation of the program.